In the third assignment, I looked into the area of regression testing, and there are two main problems faced in regression testing, and I'm actually having the same problems in this assignment, and that is scope and time. With scope, I mean that you're ordinarily testing the full product, which means that you have a lot of test cases to cover. And with time, I mean that you're running your test very late in the project, which means that there is very little time to cover this big scope. And that is an equation which is almost impossible to calculate. This means that you need to be very picky on selecting your test cases, and a few of the definitions used in this selection process is minimization, to remove duplicated test cases or test cases testing more or less the same functionality or requirement. Selection, focusing on areas, for example, where you have changed code or changed requirements. And then prioritization is certain test cases perhaps is more important to run than others, and also in which order you run them, since you want a quick feedback loop on if your functionality is working or not. So you should take the test cases that you suspect to be failing and run them as early as possible in your testing. The research paper I looked into, I stumbled upon it on a conference here in Stockholm that I attended. Is done by a Swedish company called Westermo, and they were facing the similar kind of problems. So what they looked into was that their regression test suite didn't run completely during the night time, and there were a lot of manual labor needed to upkeep the test suite, and sometimes when functionality was not working, they removed the test case from the suite and then they forgot to add it back again when the functionality was fixed, and they had no priority for the test case, so they didn't have a quick feedback loop. And also this fact that the nightly test was not finished on time, what it really meant was that when people got back into the office in the morning, they interrupted the running of the test case, and since they ran their test case in an alphabetical order, they normally interrupted the same test cases, so there were certain test cases never being run. To address these issues, they wanted to automate this procedure or the whole process of selecting the test cases and the order of them to be run, and make sure that they could finish within time. And they implemented it into a tool called Suite Builder. So let's take a look on the details behind this tool. The first thing was to fix the priority of the test case. They actually added a different prioritizers. Some has a static weight or static priority for the test case, like test priority and tag prioritizer, and then they had a fail prioritizer, which means that the test case that failed recently, it will have a higher priority to be run in the following test suite. A recent prioritizer means that when a test case has not been executed for a long time, it gets a higher priority to be run, so they want to make sure that all test cases are within the longer time period at least being run. And then source prioritizers to focus on or actually looking at the tags in the Git commits, and then prioritizing test cases in the area where code has been changed. With all these priorities, they then also needed to merge them, and then actually did it in the way that they added a weight to each prioritizer, and then they calculate an average from the weight and the individual priority given to each test case. And in that way, they get a final priority order of the test cases, which this example would be first test case 3, then test case 4, and then test case 1, and then finally test case 2. Left to do is then to look into the fact that the tests were not being run in time. And they allocated a time window and then within this window they will take a look on each test case execution, the execution time of each test case, and map as many as possible of these within this time window. So what this really means is that now there is a higher probability that the test case will finish in time, since they selected the test cases within a time window, looking at their execution time. Tests are not forgotten anymore, since they have a prioritizer for test cases not being run in a long time. And then also the test case have different priority, and the priorities are changing all the time. It's not a static and in their case an alphabetical order anymore. So then the question is, did they actually solve the three issues that they were looking into? In the first case, the fact that it was not finished within time, they checked the 700 test suites that have been run since implementation of the suite builder, and they found that actually most of them finished within more or less the time frame specified. Only a few of these actually ran over time. When it comes to the manual work needed, they actually based the result upon interviews with the test experts, and they came to the conclusion that they still needed, of course, manual work to upkeep and adding new tests to the test suite. But still, I wouldn't give too much or focus too much on this. It's based on interview. They get positive results and feedback from the users, but it's still their own opinions, so to say. So I don't focus too much on that. But when looking at the omitted tests or missing test cases, actually what they found out that within 1 month of using the suite builder, they could actually see that all the test cases that have been previously run within the 9 months time were actually run. So we could say that there were no missing test cases anymore within the longer time period. And with the fast feedback loop, what they found out was that now, since they selected the test cases that they suspected to be fail early in the run, that they could actually also see that these were also picked up early in the test phase of the or early of the run of the suite, compared to previously where it's what could really be found at any position in the test suite. So with these three, one could say that yes, they have improved significantly, and possibly also say that they have fixed the problem that they were looking into. When looking into the future of the suite builder product, what could be considered is then other kind of suites. Now they're only using it for regression tests, but they could, for example, use it for smoke test. Other prioritizers, for example, looking into new features. They don't do minimization at all. Yes, they remove test cases from suites that cannot, or test cases that cannot be run in a certain test system, but they are not really looking into any duplications. So and then also look into different kind of approaches to do this merging of the priority compared to what they do today. When it comes to my own thoughts of this research is that I like that they're not selecting a static series, and that the order of the test cases are changed within the series over time, and also that they try to select the test cases that they suspect will fail as early as possible to be run in the test suite, so that you get a very quick feedback loop that is your product working or not. When it comes to the checking of the Git commits and the tags to select the test cases within the area of the code change. Here I'm a bit skeptic that does this really work then on a large scale system? Let's consider, for example, a banking system or something like that with a lot of different 3PP products and products from other vendors. And will it actually work when it comes to these big systems? Or I think that there is a limit on how much it actually can look into. Now it probably works on a few hundred tags, but what about then when it works thousands of tags or tens of thousands of tags? Then I think that it might be difficult to handle it. And also, if we consider this research and chapter 9 of the book, which is addressing the same thing, I think that Mathur is focusing his solution very heavily on code trace executions, where he traces the code when the test case is run to see that does this test case touch this code or not. And I think that kind of approach is not really feasible because it takes a lot of time to do it. And in an agile approach, you have to redo this a number of times during the project. And do one actually have that time to do that? And if you really have that time, then why don't you run the full set? So I don't think that this approach that Mathur describes with this code execution traces actually will work in an agile project today in a proper way when it comes to a very large scale system. Finally, a few links. And as you notice, now I had the same kind of problem as I described in the beginning, scope and time. If I try to reduce the scope, I think that I could not present this information in a way that it's a bit understandable. I think that it would be leaving too many holes and gaps for you to fill in. And when it comes to time, well, I could have talked a bit faster probably, but I don't think that that would have cleared the situation either. So unfortunately, I ran a lot over time and I apologize for that.